All right, so this next one is, the name is KilpatrickT Landis, Landis, and Kilpatrick, yeah, KilpatrickT Landis. I always say Kirkpatrick. It's KilpatrickT Landis, and this, I guess, is not a patent case, but it should go on there as a, I don't know, it's commercial. It's a case of the failure of these remote reading power meters, and this happened in Canada particularly. Some utility in Canada installed a ton of these devices, which automatically report your utility readings to a central hub, smart meter. And the idea is that, you know, the days of the meter reader coming around to read your meter are gone. This is all electronically reported, which is all well and good, except these started failing in the field, like massively failing. They were losing lots of them. And it turned out there was a single component inside these meters that was failing. So this was a case against the manufacturer of those components. So we had start out with a little tutorial of here's a meter like on the side of your house, and these were residential meters, so there's thousands of them in service that send out radio waves every so often to report how much electricity you're using. So they sent us the meter, actually still up by my desk, and Al and Michael and I did a series of photographs so that we could show an exploded view where you can take off the clear cover, you can disassemble the housing to get down to the base plate, and if you turn that housing over, there's a circuit board in there, and that circuit board carries all the electronic components, one of which failed. Inside there is a radio circuit board that takes care of communicating with the utility, and on the back of that board is a component called a supercapacitor, which basically takes the place of the battery. It supplies the power to the unit, and these were failing due to manufacturing defects. They'd work fine for a few months, and then they'd start to come apart. So we took this little animation of taking a photograph of the device and dissolving to a three-dimensional model that showed what's in there. And they are made up of two little subcapacitors, which are simply a roll of a conductor and a sandwich between a layer of the separator and then another conductor, and they roll them up. It's like rolling a long strip of those together. And the capacitance is formed by the two metal conductors separated by a non-conductor. And these are new technology that gets them very close, has a lot of surface area, gives them great value, great capacity. They can store a lot of electricity, and they'll work, basically forever. They don't suffer from the chemical issues that a battery has. And of course, they won't supply as much power as a battery, but here we don't care. We can trickle charge them for hours because this sits on your utility line. It can trickle charge for hours, and then I don't know how often it reports, every hour, every day. It's a very short period where it sends a burst of radio energy out and then it stops. So it spends a lot of time charging and just little short bursts of boop, boop. So it doesn't need to store a lot of power. It sends to a radio in the neighborhood that's listening to everybody. Yeah. And so it knows your code number and how much electricity you use, and it applies it to your bill. So this was sort of the tutorial on how these things are made. They're rolled up material. They get stuffed into an aluminum can, and they're plugged with a rubber plug. And then there's a little circuit board on the end of it. And it turns out that here's a cross section if you were to cut through it and see the layers cut and then the rubber connection, and then they are filled with an electrolyte, a liquid in there. So what happened was these seals, the rubber was made, I think it was an incorrect material. They switched materials and they switched methods by how it was inserted, and it didn't form a good seal. So eventually the electrolyte would leak out. And the electrolyte is liquid, and it's a conductor, and it would short out one of the resistors that balanced the load across it. And when one of the resistors failed, it would put too much voltage on the neighboring component. Here's a photograph of the goo. It's kind of brown, nasty, tarry looking stuff. There's a close-up of the gap where the rubber didn't form a tight seal. Here's some of the goo that gets out of the capacitor. And once it gets across the resistors, notice these resistors look a lot like our capacitors that we used in the other one. They're the same kind of thing. They're a little tiny component with metal conductive ends, and they solder them down to the circuit board. And with that resistor shorted out, then one capacitor gets too low a voltage and the other gets too high a voltage, and it causes it to heat up and overheat and fail, and that's when it quits holding charge and it quits reporting your power reading, and the power company knows I got another failure. So that was a pretty detailed description with the expert's photographs and a little electrical tutorial on how the failure mechanism worked from bad rubber to a leak to shorting a capacitor to putting too much voltage on and burning out one of them.
So the product liability?
It was actually, I mean, it's a patent case. They're IP attorneys, but it's not obviously traditional patent infringement dispute. This case is still active, so we can show it.
Should we categorize it as patent? Or is it? It seemed like it was more of a.
Yeah, I don't know.
Jeff, I know you told me it was patent. How is it a patent case?
I don't know.
Yeah,
That's a good question.
Yeah, I think of that.
They told us they had a patent dispute, and then.
Yeah, and it doesn't. Yeah, it's a product failure, case, and it may be that. Yeah, I don't know. I never saw. They never presented a patent that says.
I hope we can.
This is how it works.
So that was actually for a mediation. That was not for a trial. So that was pretty extensive.
It's really cool. Yeah. But no show.
Unfortunately.
Yeah.
Will we ever get?
Yeah, it's just because they haven't gone to trial. If they do go to trial. Because actually, they told Gary that piece he has on his desk, we asked to send it back, and they said no.
All right.
So look it up and actually run it.
20,000. About.
Yeah,
19. Yeah.
They got quite a bit of bang for their buck. They got custom photography. They got. We did them. Yeah. And they sent us a meter that we could take apart.
Gary had asked them at the beginning